Welcome friends to my YouTube channel CyberiLabs. So in this video I will cover ARP in detail. So I can say that first I will cover the ARP introduction, then I will cover ARP header, and then ARP packet flow within the same subnet, and ARP in different subnet. So I will try to cover all those things with packet flow. So let's start. Let me find out the exact slide for this ARP. So alright, so if you see the ARP introduction on this slide, so ARP is defined in RFC 826. What do you mean by RFC? RFC is a request for comment. It's a proper documentation of ARP or any protocol. If you know the if you know the RFC number of any protocol, you can Google it. Let's suppose if you need to find out the RFC for TCP protocol, just look for the RFC for TCP. Then you will get this number RFC and dedicated number RFC number for that TCP protocol. So what's the use of this RFC is you will get the full information and detailed information about any protocol. If you want an expertise in any protocol, then you need to look up this RFC. Alright, so it's a process where it's a documentation process, we can say. Alright, now second point is ARP is a protocol to resolve layer 3 address into layer 2 address. As you know, like guys, I already told you, let's suppose if you want to communicate on network, you need 3 layers. You need to fulfill the requirements of 3 layers. You need layer 2, layer 3 and layer 4 information. So let's suppose if you got an IP but you don't have any MAC address, in that case you need a MAC also for that destination. So if you don't have any MAC address for that particular destination, you need an ARP, because ARP help you out to find out the IP which is, you can say, bind or which is belongs to this particular MAC address. Now third point, that is ARP stored in ARP cache on layer 3 device. So let's suppose even on your PC, because PC is also, you can say, a layer 3 device. If you want to check ARP cache on your PC, in command prompt you can type a command ARP space -a. With the help of this command you can easily find out that ARP cache. So what's the use of this ARP cache is, ARP cache basically a binding of IP and your MAC address. IP and your MAC address. In interview they will gonna ask you the one question over here. What is the difference between an ARP cache or ARP table? ARP cache, ARP table, whatever you want to say. Both are same thing. Between MAC table or CAN table. Either say CAN table or MAC address table, both are same thing. Even on ARP cache or ARP table, these both words are same. So if someone asks you like what is the difference between these two tables, you can say ARP consists of IP and MAC, whereas MAC consists of MAC and port number. MAC and port number. So remember this difference, okay? Because ARP is one of the favorite topic of any interviewer if he is gonna ask you something related to switching. So in switching, this is the hottest topic, you can say, for an interview to ask in detail, because there are a lot of stuffs to ask in ARP. Now fourth point, sender sends an ARP request to layer 2 broadcast as a destination address. So always remember there are two you can say messages in ARP. One is request and one is reply. So request always be a broadcast and reply always be your unicast. Okay, so ARP request will be your broadcast and ARP reply will be your unicast. Alright guys, and sender is responsible for the ARP request, whereas target is responsible for the ARP reply. So this is all about introduction. Let's move to the second thing, that is your ARP header. So for ARP header, like it is like important for to understand what each field consists of. Okay, so if you see over here in this ARP header pic, so this hardware type defines your Ethernet type, like which Ethernet type you are supporting. Let's suppose if you are supporting Ethernet, in that case you will find out there type 1, because type 1 is reserved for Ethernet or fast Ethernet or Giga Ethernet. Whatever the hardware type you are supporting, that information will be stored in this field of an ARP header. Then protocol type, in this field you will find out the information about the upper layer of protocol. You know this, Upper layer protocol. So now you know layer this ARP works at layer 2. So in many interviews they're gonna ask you at which layer your ARP header works. Okay, so why they will ask you? Because you say layer 2 and they will gonna ask you or cross question you, like you are saying layer 2 but it resolves your IP into MAC, so obviously this has to be work also on your layer 3. But with the help of this field you can say, sir, in ARP header there is a protocol type field where you define your upper layer protocol information. So whether upper layer is layer 3, layer 3 is network layer. On network layer, what are the protocols which works on network layer? IP, IPX and AppleTalk. So information about these protocol will be stored in this protocol type field. So let's suppose if it is IP. Okay, so for IP it's reserved for 0x8000, because you can say protocol number of IP is 8, so that's the reason in hexadecimal value we put the information about IP in hexadecimal value with this protocol number. Okay, so protocol number of upper layer protocols, that's it. Hardware length is all about MAC address, so MAC address, MAC information. Protocol length is all about IP, so information about your IP. Operation, there are 4 operations. One is your ARP request, second is ARP reply, third is reverse ARP request, fourth is a reverse ARP reply. So in our case we are dealing with an ARP, so there are only 4 operations you can say, and for whatever the operation, let's suppose you are performing, you will get the hexadecimal value in this field. So hexadecimal value for ARP, if I say it's 0x806, this is fixed, this is predefined, this is reserved, whatever you want to say. Now sender hardware address, whosoever is forwarding the traffic, its own physical address, that is MAC address. Sender protocol address means IP of a sender. Target hardware address means a target MAC address, and target IP address. So this is all about your ARP header. So I think now it is clear, guys. So for next I need to discuss the packet flow, which is very important to understand, because packet flow is all about how your traffic is moving in ARP. Okay, so for that I need 2 scenarios. First I will discuss the same subnet scenario, and then I will discuss the packet flow in different subnet of ARP. Alright, so in the case of ARP in the same subnet, so let's suppose this PC1 wants to communicate to this PC2, so it directly forwards a simple ICMP request, that is echo request. So simple communication, you are trying to ping from PC1 to PC2. So if you see this is an ICMP echo header where your layer 3 source IP and destination IP you are fully aware, 10.1.1.1, destination IP 10.1.1.2. But at layer 2, source MAC will be A and destination MAC you are not aware. Reason? Because this is the first time this PC1 wants to communicate to PC2, so you don't have any MAC address of PC2. You need a MAC address. Your ARP cache don't have any entry regarding PC2. So in this case, this PC1 generates an ARP request. Normally, people used to say this, alright, but before this, one more step occurs, and you interviewer wants to listen that is first thing, AND operation. Even before this ARP request, AND operation comes into the picture. This AND operation will identify that whether this destination belongs to the same subnet or different subnet. How? With the help of this AND operation you can find out that whether the destination belongs to same subnet or different subnet. Why? Because AND operation occurs between the destination IP and your own subnet mask. Remember, guys, and whatever the output will be, you can easily find out that whether it is same or different. I will tell you how. So if you see this, your destination IP is 10.1.1.2 and your own subnet mask, if you check, your own subnet mask is /24. So now you need to convert this and this into binary to perform this AND operation. So if you check 2410 For 10 in binary, you need to write down like this. For 1, this is very easy again. For 1, this is like this, and again for this 0 2, okay, and 0 1. So in this case 5 6 7 8. Alright guys, for now /24, you know how to convert that slash into decimal format. You are fully aware about this because in subnet mask command I already discussed with you guys, so there is no. Alright, so if you see now 0 1 is always 0. If any one of this in AND operation, if any statement is your, any input is your 0, okay, so the result will be 0. Any input, let's suppose 0 1 0 0 1 0 0 1 0 1 1 1. Alright, so this is like this. So if you do it for this also, it will be like this, and same way for this. Don't care about this because it's already 0 0, because 0 1, sorry, okay, 0 0 0 0. So in AND operation, if one statement and both statement of input in statement inputs are 0, in that case the resultant will be 0. This is AND operation. Alright guys, so if you see your output is similar to your destination IP. If your output is similar to your destination IP, it means that you belongs to the same subnet. If it is different, in that case you are in different subnet. So remember this: destination IP and your own subnet mask. Convert it into binary and performs your AND operation. AND operation is if any input is 0 or both input is 0, you will find out 0, and 1 1. If both the statement are true, the resultant will be true. Alright guys, so this is all about AND operation. After AND operation, you can easily find out that this belongs to same subnet. So with the help of this, if this belongs to same subnet, now in this case ARP request will be generated for the destination IP. ARP request will be generated for the destination IP, but in the case of different subnet, this request will be generated for the default gateway. I will discuss this later on. Now I am continuing this only. For the same subnet, you are directly generating this ARP request for destination IP. Now guys, second thing, in this case, if you check out ARP reply, so you receive this ARP reply from where? PC2. Alright, but before that, this switch will receive this ARP request. This switch will receive this ARP request on interface this first port. This ARP request from the PC1 received by this switch on port 1. As the switch receives this ARP request, first thing, switch will updates its own cache, updates its own table, that is MAC address table, where it will bind this MAC address MAC A with the port number 1, because in future this PC or this switch doesn't want to this ARP process performs again and again. This is the condition only for the first time. So as this switch receives this ARP request on this port, first it will learn the MAC address for this PC and bind this MAC address on this port. Alright, after this it will look up for this IG bit, individual group. So this IG bit will be there in your frame only. So by this switch can easily find out that whether this frame has to be broadcast or unicast. Why? Because if the IG bit value is 0, it will be broadcast or multicast, and if IG bit is 1, in that case this will be your unicast. Okay, so this is the function performed by switch. After that, switch will easily identify with the help of IG bit this request has to be broadcast. So it will be broadcasted by this switch, and now this PC2 receives this ARP request, it checks its own destination IP. So it find out that this ARP request is for me. This is my responsibility to respond back. So it will respond back with an ARP reply. If you check, source MAC is of B, destination MAC is of A, and this is type for Ethernet, and operation code is reply. Okay, and this is sender MAC address, that is PC2, sender IP, that is PC2, PC1 and PC1 IP. Alright, so this ARP reply I already discussed with you guys. This is Unicast. ARP reply always be Unicast because even IG bit of this frame is 1. So once this switch receives this ARP reply, as this switch receives an ARP reply on this port second port, it again updates its own MAC address table that on port 2 the MAC address B is there. Alright, so once it receives it, it updates its MAC table and then reply back. So now this PC1 ARP cache is updated. Now your switch MAC address table is updated. Now this time, after this PC1 and PC2 can directly communicate. If you see, after this ICMP echo request will be forwarded, PC2 reply back with an ICMP echo reply. Alright, so this was a you can say a story about your ARP in same subnet. So this is all about ARP same subnet. Alright guys, so next I will cover this ARP for different subnet. So this is a topology for the ARP in different subnet. So in topology, instead of switch, this time you will find out router instead of switch. So without router between network there is no communication. So in this case again I am pinging from this PC1 to PC2, where my source IP is my PC1 IP and destination IP is PC2 IP, but I don't have any MAC address for that. So if I don't have any MAC address, what you will do, you will generate an ARP request. But before ARP request there is one thing which is very important, that is AND operation, because with the help of this AND operation only you will find out that whether this destination belongs to my subnet or different subnet. So in this AND operation you are fully aware about that this ARP or this AND operation performs between your destination IP and your own subnet. So if your output is similar to this your own subnet, then you are in same subnet, and if it is different, then you are in different subnet. It means your destination is in different subnet. So in this, after performing this AND operation, you will find out that you will get this output, and check your own subnet, that your own subnet is 10.1.1.0, the destination subnet is 10.1.2.0, which is not equal, that is different subnet. So if it is different subnet, you will generate an ARP request for the default gateway, because the reason is this PC don't have any route to reach this destination. First, this PC don't have any route even to reach its subnet. So there is no route for the subnet, as well as there is no route to reach this host. So you know about your gateway. So if you are fully aware about your gateway, you will generate an ARP request for your gateway. So if you check this ARP request and if you check this target IP belongs to the router IP, this router interface IP to which this PC is connected. So now this ARP request will be forwarded to this router forwards an ARP reply. After receiving an ARP reply, this PC updates its cache with its IP of your router, that is default gateway 10.1.1.254 with a MAC address of B, because this B MAC address belongs to router B. Now this packet reaches to router. Now router check this destination IP. After looking this destination IP 10.2.2.2, this router find out that this I don't have any MAC address for this IP. Even this router, because router is also layer 3 device, this layer 3 device also maintains an ARP cache, and in its own ARP cache this router don't know the MAC address of 10.1.2.2. Alright, so what this router will do, this router will generate an ARP request. So if you check in my diagram, guys. So ARP request. So if you see this ARP request will be forwarded by this router. So if you check, the sender IP is 10.1.2.254. That is router this interface IP. Router second interface IP, this interface. Okay, wait a second. So this interface IP. So 10.1.2.254. This ARP request is forwarded from router to PC2, and the sender IP is the interface IP of your router, and the target IP, if you see, the 10.1.2.2, which is from here. This router came to know that this IP, I need a MAC address for this. Now after receiving this, because this ARP request is broadcast, this PC will receive this broadcast. After receiving this broadcast, it will find out that this target IP belongs to me. So this is my responsibility to respond to this ARP request. So this ARP reply will be forwarded from this PC2, where this PC2 provides a MAC address of its PC. So now this router, after receiving this ARP reply, updates its ARP cache that 10.1.2.2 belongs to the MAC address D. MAC address D. Alright. So after receiving this ARP address, after receiving this ARP MAC address, this router first updates its on ARP cache. Okay. Now after receiving this, after updating its on ARP cache, if you check, this is an ARP reply forwarded from PC. This is an ARP reply forwarded from PC. PC to router. So see this. This is D. This is D. And the source IP is 10.1.2.2. So this ARP reply received by this router updates its cache. Now this router fully aware about that 10.1.2.2 MAC address is D. So this echo will be forwarded to this PC. PC for response back with its echo reply. So this is the story about your different subnet. So this is how ARP packet flow in your different subnet. So this is the final communication. If you see, this is the final communication. Okay. So I am done with the packet flow of this ARP. So both the scenarios are covered. Proxy ARP and GARP I will cover in the different video. So thanks for watching this video. Bye bye, take care. Please like, share and subscribe this video.